Hello Year 10 and welcome to our lesson on refraction. As a recap from last lesson, pause the video and look at this slide. Which of these objects represent specular reflection and which ones represent diffuse reflection? So remember, diffuse reflection is from an uneven surface, so the light is reflected in all different directions. So in this lesson we're looking at refraction. I'm going to go through in this slide how we carry out a typical refraction practical in the lab, and I'm also going to include a web link to a YouTube video that shows somebody doing just this. Now if we have a look at what I've written here, we would normally get a piece of A4 paper and then select a rectangular prism, and that simply means a rectangular block of glass or perspex, something which is see-through. We draw around the block, remove it and then construct a normal line at 90 degrees, and I usually suggest towards the top left of the block, although it doesn't really matter. Remember, in maths the word normal means 90 degrees, so we're drawing a dotted line at 90 degrees to the block, and that's the boundary that the light is going to pass through. The other thing I mentioned last time is that we always measure all of our angles from that normal line and never from the mirror line, or in this case from the line which shows where the block is. We then replace the block, get our ray box out and shine a ray of light along that 30-degree line towards the block so that it crosses where the normal line is. We would then have a look to see what happens as the light passes through the block and comes out the other side. This diagram shows the results of that practical. And again, in the blurb below this video, I'll put a link to another video showing this practical in real life. Now, as we can see here, the light ray appears to change direction as it goes in and out of the block. Now, the first thing we need to think about is what's happening to the light as it enters the glass block. It's going to slow down. The block is much denser than the air, and it's going to be harder for the light to travel through. So it's going to cause the speed to reduce. So the speed of light inside the block is going to be lower than the speed of light outside of the block. This always happens with refraction. Refraction is all about waves changing their speed as they go into something with a different density. As we can see here, as it enters the block, the light ray changes direction, bending towards or nearer to the normal line. As it goes out of the block, it bends away from or further away from the normal line. Having done this practical in the classroom, I always ask my classes to repeat the practical, but this time to shine the ray of light straight in along the normal. Now we know that as the light enters the block, it's going to slow down. The question is, will anything happen to the direction of the light? This diagram shows the results of this second practical. And as we can see, the light ray shines straight through the block. It doesn't change direction at all. So here we see that the light slows down but doesn't change direction. Now in the last lesson we looked at both ray diagrams and wavefront diagrams for reflection. And we need to be able to do exactly the same for refraction. This is particularly true for the triple science course. You're much less likely to see this if you're doing the combined science course. As a reminder, when we're drawing the wavefronts, we start with the ray diagram, add the wavefronts afterwards. They should always be drawn at right angles to the rays. The additional thing we need to think about here is that from our equation V equals F lambda, we know the frequency of the wave must stay the same because it's a light ray of the same colour. However, we do know that the velocity is going to decrease, it's going to get slower. So for this equation to hold true, the wavelength must also get smaller. The wavefronts are going to get closer together. These two diagrams illustrate what I've just described. So on the left we started with a ray diagram, and we can see the ray coming in, and as it goes into the glass block, it's getting refracted, it changes direction and moves closer to the normal. On the right hand side we've drawn the ray in as before, and then we've added the wavefronts, remembering they must always be at right angles to those rays. As you can see, when we get to the boundary where the wave is going to change direction, we've drawn the wavefronts much closer together to represent that smaller, wavelength. Remember, as it slows down, the wavelength gets smaller as well. As it speeds up coming out of the block, then the wavelength will increase again. For those of you doing the triple science course, this diagram shows a little bit more detail, and you can see that we have the ray going down the middle, which is in grey, and on either side we see the edges of the wave, which remain parallel throughout. So that's a quick review of refraction. Pause the video now and have a look at these 4 examples. Which ones of them are right and which ones of them are wrong? I hope you got all 4 of those correct. That's the end of this lesson. Thank you for listening.